Then the next step is, so all those that design, how do you design a computer program? So that is where algorithms come in. So algorithm is basically a sequence of actions to complete a given task. So algorithm is essentially a series of steps to accomplish something. Do we use algorithms in our daily life? Yes, we do. So for example, like the book states that it's like a recipe. So what is a recipe? Recipe says take this much sugar, this much flour, this much salt, combine them, heat it for this much time, and you will get something, right? Similarly, an algorithm in a computer language sense says that take this, take that, do this first, then do this, and then do this, and you will finish, and you will get a finished product that does something. Okay, so algorithm essentially is a sequence of those instructions that you want the computer to do. Are they written in Python or in C++ or in any other language? No. Algorithms are series of steps that you envision or you design in your head and on paper. Okay. So I tell you everybody that for this class, always write an algorithm before you start writing code. Okay. Meaning the design, that what you're trying to solve, first solve that on paper in a series of steps, and then take those steps and start writing the code. Okay. So algorithms hence are simple plans. Okay. Examples given that calculate the area of a circle, for instance. Okay. So the area of circle is what? Pi r square, I think. Yeah, pi times radius square, right? So so the first step in designing this algorithm is, what are your inputs? You already know the value of pi, right? Then what do you need from the user is the radius. Whether you can get the radius directly, or let's say the user can input the diameter, you can divide by 2, get the radius. Okay. So let's say you get the radius. So your input is radius. So that the first step is figuring out what are the inputs, what are the outputs. So my input here is radius. The output is the area of the circle. Okay. Then the step, what is the step? How am I going to find the area of the circle? I know the formula is pi times radius square. Okay. So now I already have the radius in the input. So when I write my code, or when I write my algorithm first, I will say I need to take the r, radius, and multiply it with pi. Okay. Pi's value is constant, and we already know that 3.14 something. Okay. So in my algorithm, I will take the radius, multiply it, and then my output will be the area of the circle. So that's how you design algorithms. Okay. So this is a very basic example. Some problems are more complex. Trajectory of a missile, for instance, shuttle launch sequences, designing any kind of input-output program, a word processor. So these, you can imagine, are huge programs that take series of steps, right? A sequence of a lot of steps. And if you click this, then a set of instructions is executed. If you do something else, another set of instructions is executed, right? But the basic point being that there is a series of steps that you need to know beforehand that you can start writing code. And those series of steps is what an algorithm is. Then the next few slides give you an example of like if you have this kind of a problem statement, how are you going to calculate the interest over a given period of time, per year, let's say. For let's say some amount of years that you hit a certain amount, right? So for instance, the example states that you have 10,000 in your bank account and you earn 5% interest. In how many years can you double the amount? Okay. So then the slides tell you how are you going to solve it. Okay, so you can read it in detail in the book, but the point is that how would you solve it? You make a table, something like this, that your beginning balance at year zero is 10,000. So to get it to double means that you have to stop at whenever you get your amount to 20,000. What's your per year interest? You multiply the the previous amount by 1.05. You get the new amount. You take that amount, multiply by 105, and it keeps on going. When you hit 20,000 here, that's when you stop. Okay. So that's our general thing, that you write it on paper. Okay. That these are the steps that I am going to execute. And then you break it into steps and you write what you need to do. This becomes your algorithm. Okay. Then there is something called a pseudocode. What is a pseudocode? Pseudocode is the one step above the algorithm, but it's less than the actual code itself. Hence, pseudocode. So pseudocode is that you take this and translate into some kind of code that you can easily write into the Python language, let's say, or in any language for that matter. Okay. And when we start writing more code, then it will become clear like what a pseudocode is. So for instance, when I say repeat the steps, so how do you repeat a number of steps? So you have written these 3 steps. How do you repeat them in a programming language, right? So it's in English language, it's easier to say repeat the steps. But how does the computer know, right? So a computer has specific constructs to say, okay, start repeating these 3 things. So you will write a construct up here that will tell the computer or the compiler that you're going to repeat these many instructions. And when you write pseudocode, instead of saying repeat, you can just write that, say, let's say a loop. You can say loop with these instructions, or repeat with while loop, repeat with for loop, repeat with this loop, those loop. So those are the constructs that the language has specifically defined. But in your pseudocode, you can just say, I am going to use this type of loop here. And loop means that it will repeat those instructions. Okay. So again, as a recap, you have to write algorithms for things on paper. And your algorithm is essentially a series of instructions that will be performed telling the computer to do something. You will take that algorithm, translate it into Python. You can write a pseudocode directly. So the step is that you can either write a pseudocode or write an algorithm. Okay. And then you can take either of those and translate into the actual Python code. But definitely always try to write an algorithm or pseudocode of it.